Welcome to the rendering lecture. I will tell you some basics about rendering. Some stuff you might already know, some may be new, I don't know. I'll just give you a wrap up about the render techniques. You will use them for rendering the city models you're coding at the moment. So let me just give you the agenda. First, I'll cover computer vision as a whole. Then I will dive into the topics you may already know, and then I'll just quickly speak about photography and light. Computer vision. One topic is image processing. Actually, it's divided into, here in my speech, I divided into image processing, which is more image-based, and then geometry-based image creation. So this means, yeah, you can imagine you have a 3D scene and you want to take an image out of it. And here we're speaking of having a picture and want to get information out of it. So one big topic in computer vision is to find segmentations in images so that a computer knows which objects are in an image. This is done with several techniques. One is finding edges, the other is threshold. There are others. There are also methods which try to look up known objects in databases and compare them with what they actually see at the moment. Other techniques are stereo graphics. So you have two cameras, and if both of them see the same object, it has some relevance. Yes. Of course, what you know from Photoshop, the whole image filtering section is covered in that part of computer vision. Here a blur filter. Then the stereoscopy and the 3D scan, which I already tried to speak about, so that the camera or the computer can analyze a picture and sees, as we would, can recognize faces or gestures or can reconstruct buildings from images. And then the other part is what I'm going to talk about. That's image creation from 3D shapes. First, you have the rasterization. The problem is you want to have a 2D image of a 3D scene. So we project everything that's in the 3D scene here on a 2D plane. And you do that with one eye point here. And this is a very old example, but very similar. They're using some kind of rays that connect the eye point and the object. And the point that goes through the plane is then the point which is on our image. And the same kind of projections are covered in computer graphics, a bit more abstract. Here you have the frustum, that's a cut pyramid. And this actually defines the perspective of a 3D camera. So you have a near clipping plane and the far clipping plane, which defines which 3D geometry is projected onto the the 2D plane. And here we have the same, but it's not perspective, but orthogonal projection. So just that you can maybe memorize the image. It's you don't have to remember these numbers or something. It's just so that you saw. And then there is ray tracing. Maybe I can give you just another word. This is what basically covered in OpenGL and DirectX. So what you see on the screen, that's what can be calculated very fast. What's done on the hardware, that's what you see when you're in your 3D program and navigate around. And then the bit more complicated stuff is ray tracing and physically based rendering. They begin to get very fast, so you can see them real time. You can almost see them real time at the moment if you have fast graphics card. But they used to be very computational intense, in meaning you had to wait a long time. But it works a bit more sophisticated. So you can not only detect shadows and objects, but you can also render refraction. As you can see here, this is what you cannot do with OpenGL or DirectX. Maybe you will be able to do it in the future, but it used to be too complex. Yeah, and here maybe just to make it complete, this is a recursion. The ray you have here starts from here again, and actually it could spread as long as you want it to spread. It also depends on how much time you have. And then that's what you probably already know from rendering in your studies. That's what you maybe also know, but generally it's covered under physically based rendering. And what makes it physically based is not just the bidirectional reflections you have here. That's a function that maybe I can quickly explain. Here you have a ray that goes in only one direction. You have your eye point, and then you want to know, what does my eye see? And in this function, you also have the material has another the material is different, more accurate, also reflecting towards where the light comes. And to make it really physically accurate, you have to obey some rules. So this function should never be below 0. There are some other rules here. There is also the integral over the whole function that must be below 1, so that makes it physically correct. And you also have subsurface scattering, meaning some skin type materials, or you could also render milk with that. Basically it works, here you see how it works. So light goes in and it's being lit a bit more deeper than just the surface. But that's actually still not enough for physically based rendering, because you have to, if you want to be physically correct, you have to base your rendering algorithm on the wavelength, not just on RGB, because RGB is very made for the human eye. So when we see a color, it's actually a spectral power distribution over a certain wavelength. You all know that that's electromagnetic waves. We see them in a certain range. But when we perceive a color, it may be two totally different curves. And to make it physically correct, you also have to base your algorithm on wavelength and not only on RGB. And with that, you can have correct special effects, correct additional effects or light, actually, which you couldn't have with not that accurately with other render algorithms. So, for instance, the soap bulb or the luminescence. Maybe you've seen that already when somebody drove by with a special painted car. First it's red, and then once passed by it's blue. So that's this effect. And just to give you a quick demo how this could work, there is a new open source engine that renders physically correct, or at least aims to. Maybe it's about here at the moment and aims to implement the other features. But still, it's a different algorithm, and it's faster, and it's running on GPU. So you may be interested in try it out, or you maybe have your own render engines which can do it already. But since I don't want to promote any render engine, I just show the open source. And here you can actually should be able to tumble around in real time and almost real time, and then it would calculate the image again. So actually this covers already a lot of materials. I just want to note another small thing. Well, actually some things. When rendering with traditional rendering engines, I just want to quickly show you the difference between specularity and reflections. Here you can see the specular channel having a snowflake on the texture, and that's not reflection, that's specularity. So that's this white point you see in the material window. Reflection is something different. You can also have it on the graphics card already. And I can show you also a quick demo on that. This works with environment maps, And I'll probably have it in the keynote, the link. These are actually pretty cool. You can give the whole environment, either the whole environment, a map you can download here, or you can give an object a reflection map like this. And then when you tumble around, it reflects, not physically accurate, but it seems to be realistic. So there you have to trade off how much time you have, what effect you want. Do I want it physically correct, or what can I do without physically correctness, but with fast tools I have at hand? So this is just a tool. The link should be in here as well, showing you how to set up such reflections. Then, at last, a short note about bump maps. You shouldn't use them. Use instead displacement maps. Why? Because you don't have a silhouette shadow here. You see that? You don't have the mountains, the Himalaya, giving a shadow below here.
So you mean the other way around. So you should avoid bump maps, but use displacement maps.
Yes.
I guess you say that's the way around.
Okay. Use displacement maps, not bump maps.
It's like 5 times more to render a displacement map.
Okay.
I don't know, maybe in some certain edges it's different. I mean, because one of them is seriously giving it 3D effect is a mistaken gather. The other one is just engraving thing. It really takes a lot more time to use a displacement map.
The one thing is just working on the pixel level, so like post graphics effect, and the other one is really affecting the geometry.
Yes, but maybe that's a good side note. Use it as you want it. Yes, if it's not necessary, then don't use.
You can have not to configure with your following slide.
Yes.
You could introduce an image target where you have low resolution displacement maps for far camera distances and so on. You can increase there just partially. So that could be possible with tools with Blender or Armio or something else. Depends on the shaping it from later on.
Yes, that's the next point, level of detail.
Sorry.
When something is far away from the camera, you don't have to have high resolution. So for an image like this, you don't have to use geometry like this. And yeah, that's maybe you can use displacement maps, but on a low resolution poly, then it maybe doesn't affect the render time so much. And here I found another demo, which I found it was very cool. And let me just quickly show. This one here. Here you have well, I don't go into the details, but the principle is you can move the camera away, and then the mesh will lower its details. So when I go away, you can see also here the subdivide of the mesh, meaning the amount of detail is decreasing. So here it's 1, And then I go a bit closer, and then it's for much more detail. You can see again here it's also, no, it's also a graphics card trick looking already pretty realistic. So sometimes you don't have, sometimes it's worth to learn the tricks. But I know they're pretty hard and they always change. But I'm amazed all the time. Well, so far about level of detail in this particular configuration. Of course, level of detail always depends on your image. You can also lower the amount of polygons manually by just clicking on a building or on a very high resolution polygon and trying to reduce the amount of polygons. There are some techniques actually to reduce the polygon count, but I didn't cover them here. But you'll surely find some tutorials in the internet. Retopologize, it's called. So they're using it often for faces, where they're having a lot of details when modeling faces, and then when they want to animate them, the amount of polygons would be just too high to animate them, and then they bake their modeled shape into a texture, and then they reshape actually what they have modeled before with a lower polygon count, and they apply just a texture on top of it, and it looks realistic, but they still can move around the geometry very fast. So that's what I wanted to say about level of detail. And then I'll give a quick introduction to linear interpolation. It may look as a technical overhead in first place to you, but actually it's very easy. You just interpolate between two values, and the mathematical part of it isn't that hard actually, but I just show you how it works geometrically. So if you want to scale up an image, meaning if you have Photoshop an image with 100 by 100 pixel and you want or should have it by 400 by 400 pixel, the algorithm needs to interpolate the pixel between. And if you don't interpolate, it just gives you larger pixels. And with interpolation, it kind of tries to find out which color it has to take between two pixels. So if I have a white pixel and a brown pixel here, it doesn't make an edge, but it calculates the difference in between. And here you can see that also geometrically. If I have, that's the same we had before, but bilinear, meaning we're trying to find that point here between four values. And that's, you don't have to know that actually, but it's maybe good to have heard of it when it comes to a level of detail in texture space. First, maybe let me give you another hint. These are also bilinear interpolations. If you move around this point, there are some techniques that the mesh is correctly interpolated. And we used that when we did the projections on the facades last December, and we're doing this year again, having projections on the HPI building, where we try to map a movie or an interactive program to the facade. And this is just a simple explanation how this would work. You take the mesh, and these points here are all interpolated. If you don't do it like this, you may end up having your plane and want a texture on it, and when you don't subdivide it, then your texture gets cut here in the middle, because textures are always triagonals. Then your texture is just not correctly warped or transformed. And you can kind of see this here as well. If you have a texture and just scale it bilinear, you may, as we've been speaking about just before, want to reduce the size of the texture when it's far away, so you don't need so much memory in the graphics card. And if you don't interpolate also in the z-axis or in the depth axis, you end up with having just the borders of the textures being visible. And here you have to interpolate as well. Then when you're doing a picture, you may also want to know just the basics about photography. You may already know. There is a nice feature in photography called depth of field, which gives you the focus in a picture just on one, maybe narrow range, if you want to express something, if you want to make a background blurrish and have a face in the foreground, for instance, or if you want to just give it this effect of having depth in the picture. And you can do this with some physically based renderers as well already, having the aperture of the 3D camera being wide open. That means that the range of where the image is actually sharp is much more narrow. So this works in reality as well. If you have a camera, you may want to have a lens with a wide aperture so you can use this effect. And then there is another feature, the lens shift. That's a traditional trick actually in photography, where photographers make buildings look like as if they would have been drawn, or just make them in the same language as you would have drawn them. So in reality, you see a building vanishing in all three directions. And when we draw them, mostly we just have two vanishing points, and all the vertical lines are really vertical. So I assume that's because it's looking more solid. It's just an old habit, probably, but it's still being used like this, and still shift lenses are used, and photographs are taken like this. So maybe you know already how to deal with that, or otherwise I could give you a short advice in the break. It's just a small number in the parameters of the 3D camera. Yeah. Then photographers are also light specialists. So if you're going outside and thinking, wow, that's nice light, that may result in nice pictures, but photographers usually try to control the light. And the traditional way to control the light in photography and also in cinema is the three-point light. Here we have a key light, which is the main light, and here we have shadows, and you want to fill them. And then you have also a background light. So that's just the basic setup with the three-point light. And having 3 points light in traditional renderer algorithms, that's also much more time efficient, because point lights are much more time efficient. The computer doesn't need to calculate so much as if you would have a large area which emits light, and then much more rays need to be calculated. If you have a point light, it's much easier for the computer. So if you don't have such a powerful machine, or if you want to light up a game or another scene where you don't have so much power left, three-point light is surely a thing you have to look into. And then there is also, I found a package, a studio kit, which has here for cinema actually the lights you would use in a photo studio as well, which then gives really realistic results just with the cinema standard render. Yeah, maybe you just have a look, or if you're not interested. I got just really stunned with what you can do.
Sorry, could you use actually an environment map as well? If you have those point lights, just as like luminescence information in your environment map, you could actually use it in Blender or anywhere else.
Yes, and environment lighting is also a very good technique, which I haven't included yet in this talk. So yeah, that's a good hint. Environment maps, as I showed you before, the reflection map with this sphere-ish looking texture, that's a good technique to light up your scene. It's looking really realistic because you don't have one source of light, but the source of light has also shadows in it, and gives just more vibrant reflections as you see it here or here. That's looking automatically more realistic. And the hard thing, I guess, is to create those environment maps on your own. I didn't have figured out a nice way yet to tell you. I just, for the moment, I'm stuck with the textures I found on the internet. And Jan told me if you have Vue, that software that renders the nature environment, it renders really nicely trees and stuff. It also can export such environment maps, and maybe that's a nice hint to maybe use those. Do we have Vue in the computer cluster?
Used to have, but I don't know if the license is selected, otherwise you need to purchase again.
Okay.
It doesn't cost as much. Maybe another hint is HDR shop. like I thought it was an open source application. They can easily stitch things together, get over to this cubic or the sphere-based environment maps.
I found a tutorial on the internet where it states you have to make 64 images with a camera on a tripod and then stitch them together manually. But I didn't try it out yet, so.
And there's Hydra, this is a Mac-based application. I'm not sure if it's for PC. They can use a range of photos, as you said, images, and stitch them together again. So it does automatically the stitching as far as I know. And compute them from there, this HDR, but it is commercial.
But still, that's something actually you could have a look into and prepare when you're not in a hurry for a crit, and then when you're doing your rendering, could easily import the texture.
But even sometimes if you're just faking, you're not using HDR, or you can use any image for lighting, so very fast calculations, very nice. You combine it with activity, with some acuity, with windows or whatever, then you have already like a very stunning looking photo without having too much boarding on the calculation side. It's very fast. It's very soft information you have there.
Or recently I found you can buy an enclosure and put in a graphics card and connect it with Thunderbolt to your Mac, and then you're all set as well. But I think this will take some months from now when it really comes to market. Okay, and then there is the usual post-processing you definitely know already. I just want to give you another short insight on how you could do it without Photoshop, even kind of procedural. That's when you use, do you know After Effects? Or you've heard of? So there you don't, you're not editing an image directly, but you just apply filters on it. And that's what you can do here as well. And the good thing about is, if you're doing an animation, it's applied for every frame. So you don't have to Photoshop every frame of your animation, but it's sort of like graphically programmed what should be done with your image. And yeah, will be applied then for all the frames. And of course, Blender here is not so powerful as After Effects, but it's free, it's open source, and you probably for special effects with After Effects you also have to load in plugins. There are many plugins for After Effects, and they would cost then as well again. So it's just an alternative I could recommend from a student's point of view. So yes, that's basically it. Thank you. Are we having a break? Are there any questions?
So when we would like to render the final model in City Engine,
Mm-hmm.
how does it work? That we plug in a certain rendering machine to the City Engine, or do we export the file from the City Engine and render it in another place?
Yes, you need to export it. There are we have a reality server
our case was supposed the idea would be as follows, that you export all your data on which you created into a so-called mental images format, mental array like media, and we have a special vendor which runs on GPUs in the basement, and then we try to integrate all your data together into one model, and then just render this one. And ideally for the presentation, you can just show it from the website of the web server of this vendor.
But maybe it would be nice to have some maybe pre-rendered images just to highlight,
Yes.
so that we're not fully dependent on the reality server.
Yeah, of course you can just write your models out in any kind of format. For instance, you can use FBX, and then you can import it all the right textures, distortion free to 3ds Max or to Maya or HS Cinema as a FBX importer. This is one of the most recent file formats, so which is actually really outdated when it comes to 7 layers of textures. You can actually already assign things in here. So you don't need to set up your material framework again from scratch. You just do it once and you can just take it with you. Another possibility, I think you can 3ds it over JPEGs as well. So
3DS.
3ds is as well.
Yeah. It takes all the textures and everything.
Yeah. But if you're using Max anyhow, you can just use FBX. It's slow on the import side, but the results much better. Yes.
For example, I'm generally trying to use V-Ray. But I don't know, for example, how efficient it is when rendering this kind of large, like a city scene. Because I don't know, I never heard.
You can use it, it's working quite well for city engine geometries. V-Ray is a monster when it comes to geometry.
Yeah.
But you need to, as Lucas said, you need to find out what will be the right composition, the right recipe.
Yeah, exactly. Otherwise it takes days and it really has to be well set up, I think.
For instance, for a city, if you don't have too much close-up, you can leave all out of the ray tracing based materials. You just need to assign very simple materials like Lambert, for instance, these kind of things. Don't use formulas, bling, all this kind of stuff. You cannot see it at all from far away. I think even with some Lambert shaders, it's even possible to set up reflective maps. So you really put away all those kind of ray tracing issues that you usually have if you are from indoor visualization or from just outdoor to indoor looking inside. But if you're just from a far viewpoint, global illumination or ambient occlusion is very nice already, and it should fix it quite well. So, just as a tip for V-Ray.
Yeah.
And we have cinema upstairs
with
V-Ray, so it would be probably best to export from City Engine to cinema.
Last semester some students did as well as a Rhino workflow. They imported everything from the OBJ in Rhino and used we have V-Ray for Rhino to do as well.
Okay.
So there are thousands of options, I guess. And as well as the new 3ds Max, they have this iRay feature, which is similar to what you showed here. So those as well.
It's really slow.
Ah, okay.
In my computer, I don't think it works.
It really depends on the graphics card.
Yeah. The laptop, it's just kills the laptop.
I think it only runs on NVIDIA graphics card, so if you have an ATI, you're out already, for instance. Sometimes on laptop you have ATI, most recent have.
Yeah, I mean, I have an external graphic card, but the thing is, I don't know, it's not like it's an old computer, but it's just, it becomes just such a pain to do it, like all the time, so you just cut off the effect, and you say, I'd rather just model it and then render it, because otherwise it takes you ages to model this.
Okay.
In a slow computer, I mean, maybe this kind of thing is good.
Well, if you have a fast computer, it helps.
Always.
Yes. Okay.
Yes.
15 minutes break.
Yeah. So, like, oh, yeah. So we're meeting again at 30 or, yeah. Now we have 5 after. But just to, yeah, at 30 I guess. And then we do this purchasing demonstration. So maybe just as a comprehension, so today there are like 3 parts. One part is just the continuation of the last thing from last week with the GIS. Actually now it's the more interesting part, how to actually write out something and get it into City Engine. And then you will get the already existing City Engine model of Altstädte.